Welcome back to Truck Tech, everyone. This is Alan Adler, your host. This is the last episode that we're going to do with the Volvo VNL this year. And we're going to return to some things that we talked about early on. Today, we're going to talk with Kyle Zimmerman, who is out of the communications function, but also has become pretty conversant, Kyle, in a lot of the powertrain areas and fuel economy specifically.
Yeah, for sure. It's a busy year for Volvo Trucks, obviously, that we just got through. Launching the biggest product in the history of our company here in North America. So a lot of opportunity to get outside your traditional box of work and really get into other areas and an all hands on deck kind of approach to a launch.
Well, and I don't think we can overestimate the significance of the first purpose-built over-the-road truck in North America for North America.
No, you really can't, and we were very successful with the VN launch here in North America. And honestly, when they launched it back in, 1996, when they brought the first integrated sleeper in North America, really that truck was way ahead of its time. And so when we look at now, that truck was an adoption of the Volvo FH, which is, 30 plus years in existence, around the globe, is one of the best selling trucks on the road. We've adapted the product since then from that platform. Now we've had an opportunity to give our engineers a blank sheet of paper and say, hey, the duty cycles, the applications, things are different here in North America. Let's build that truck that's purpose-built for North America, purpose-built for what our customers are going to do. And I think we've delivered another truck that's ahead of its time, but it's going to benefit our customers today, and it's going to carry their businesses 20 years into the future.
Well, I was going to say, this is 10 or 15 years at minimum in terms of an all-new truck. And when you talk all new, 90% new anyway, that's a huge thing. You talked about clean sheet, and I think the idea that you're able to do that really from all the topics that we've covered over the months here on Truck Tech with the VNL. Now, we're going to come back a little bit. We're going to revisit some stuff that we did early on with Dwayne Teagles in powertrain, and you were there, so I'm sure you remember it. But one of the things that is so interesting, and I think a claim that has to bear out, and that is up to 10% better fuel economy.
Yeah, so up to 10% fuel economy. So what we did is we took a baseline of what was our current product at the time, so that the VNL had been up and down the road. That baseline was set with the most aerodynamic version of that truck that we had. And then we took this brand new Volvo VNL 860, and that was where the benchmark was. That was the baseline, if you will, was the comparison there. So what we did to achieve 10% fuel efficiency, you can simplify it, breaking it into two categories. First was aerodynamics, and then was powertrain. So from aerodynamics, we see about 7% of that 10% gain. So quite substantial. I think when you look at the truck, obviously the aerodynamics kind of jump off the page. And I know you're familiar with it, and I'm sure a lot of your viewers are as well, with the Department of Energy Super Truck program.
Yes.
Super Truck 1, Super Truck 2. As you look at those two projects, Super Truck 1 was really developed in parallel with our last product line, with our current VNL. And then when you look at Super Truck 2, that was designed in parallel with what we have now with the all-new Volvo VNL. And we love our partnership with the Department of Energy because really it takes our advanced engineering team and affords them the opportunity to have what we call a live innovation lab. We don't look at that truck, the Super Truck, as a one-off demonstrator, as it's classified. We look at it as a live innovation lab. So we can really try things with that, prove it out in real-world validation, computer modules, to see, hey, what can we commercialize with this? What can we commercialize today? What could we commercialize in 10 years? Maybe what can't we commercialize, right? Because there's certain things in Super Truck that aren't going to cross over. But when you look at Super Truck 2 and you look at our all-new Volvo VNL, you see a lot of those aerodynamic styling cues, right? You see that wrapped and bonded windshield that's got a much more gradual slope on it between the hood and the roof line. Really helps us transition that air smoother. You look at the sides, very similar. The very rounded front bumper. How we took the hood and we really shrink wrapped it around our powertrain to give a really aggressive wedge-shaped design from the front bumper all the way back as the truck starts to flare out where you would be connected to the trailer. So aerodynamics was a key place for our engineers to work to really start to achieve that fuel efficiency, because through aero, right, we've actually got a chart that we showed during our launch activities comparing the legacy VNL and the all-new Volvo VNL.
So Kyle, when we talk about 7% coming from aero, and it's interesting that you brought up Super Truck 2 because, we had an opportunity to see that, walk around it, get in it, things like that. There are certain things, whether it's a 48-volt power system or whatever it is, you talk about the future. Maybe that is something that you can do down the road. But today, and on this truck, from an electrical system perspective, you've now become common on the 24 volt that they use in Europe. So there's a lot of opportunity there to do things the same way, right?
Correct. So I think what we've seen in the past, right, is that we can develop a technology in Europe, be it active safety, be it any of those things that run on the electrical system, and if we would bring it to North America, we would have to re-engineer a little bit to fit on the 12 volt platform. So by moving to 24 volt platform, we should see a much quicker technology, not just from Europe to the United States, but we can develop things here that can go there. So we're going to see a lot more of that cross-pollination, I think, in the future between our products. So that's going to be great. And then in addition to that, 24 volt architecture allows us to put less amps through things, should prolong the life of some of the components. Also is going to lead to faster diagnostic times. We've got some more wiring harness connections within this truck now, so you can really isolate those problems faster, which is going to be a huge advantage to our certified dealerships.
Sure. When we talk about, and I'm going back to this, but when we talk about 7% of this fuel efficiency improvement coming from air, the other 3 comes from powertrain. That in itself is pretty remarkable. In layman terms, please, because some of our audience is layman. Give us sort of the highlights of that.
Yeah, so there's a lot of areas, again, that we talk about. We gave a blank sheet of paper, so to speak, to our powertrain folks. The actual size of the engine didn't change. I like to say that when we talk about the aero component of shrink wrapping the engine compartment, tightening that hood up, the actual size of the powertrain didn't change, but what we did within the engine itself. We redesigned the wave piston. We had the patented 6-wave piston. We now have a 7-wave piston. But you think, okay, you added a wave to it. What's the significance?
Yeah.
Well, by doing that, we're able to actually disperse heat across a broader surface area on the piston, which is going to help us reduce our NOx output. Mm-hmm. Then with that, we're also able to control even more precisely the spray of fuel and the mixture of air that happens in that compression, in that power stroke. So to complement the 7-wave piston, we redesigned the injector. Obviously, it went from 6 holes to 7 holes and has a smaller needle control valve, which eliminates some of the extra fuel spillage that you would get in there. So that's going to eliminate some diesel particulates as well.
So Kyle, you mentioned NOx as one of the things, and there's a tremendous amount of effort now going into that. Volvo recently announced a CARB compliant engine for 2024. Reducing NOx is not really an option, and it's something that, quite honestly, since it's smog forming pollutants, it's something that we want to reduce as much as possible, just for our health. What is it that you were able to do in the 2024 variant, which is principally a California truck, and those states that follow? What areas have you really looked at and been able to impact?
So when we look at our after treatment system, particularly, so we're reducing NOx through the piston design, and we're reducing diesel particulates coming into that after treatment system by that new needle control valve. But in the after treatment system itself, we went from just having the diesel particulate filter being serviceable or replacing the entire box. We can now service it in 3 individual components. So we can service the entire DPF, we can service the entire select catalytic reduction system. Really what we do is we can go through there, our diesel DEF mixing chamber, all of that can be individually serviced so we can keep those products on the road longer for our customers, improve that uptime, lower their costs. They're no longer replacing an entire after treatment system. Now they can replace it or repair it, section by section. Yep. So it's going to keep that running, which sustainability is very important to us at Volvo. So that talks about emissions reductions, right? But also that's raw materials, right? Because now that one box system is now serviceable in 3 units. Yep. So we can keep that going, less raw materials being used there. Now back to your original question though about the CARB 24 engine and that after treatment system. So same after treatment system in principle. It has in it a 48 volt heater. So that heater is going to help us at startup and then at idle situations where you need that extra heat to reduce NOx output. With that, we've put a 48 volt alternator on the engine itself. So the engine looks a little different, but it's same internal workings, right? It just has a 48 volt alternator to then charge the 48 volt batteries that come with that truck.
And eventually, we mentioned 48 volt a few minutes ago. Eventually, you can do more than around 48 volt, more functionality for the truck eventually.
Yeah, of course. We're always looking at those future technologies and the way that we can improve our products and move into the future.
How does CARB 2024 relate or get you closer to 2027 greenhouse gas? What
I think honestly, Alan, it's just a constant product evolution. It's continuing to refine those products. It's continuing to refine within our engines. I mean, when you look at where the diesel engine or the internal combustion engine, I like to say, but where that technology has come since the 80s, 90s, even early 2000s, I mean, we're building much, much cleaner trucks today, better emission systems. Those after treatment systems are phenomenal now. And we just continue that technology and prepare for the future.
mm-hmm. Is there anything else on the fuel efficiency side that plays in? You took us through the powertrain changes, and you can see it in the aero, honestly, in the truck. I mean, the wedge form in the front, things like that. We've had discussions, with Brian Balicki in design about that and about what went into it and some of the things they had to consider that maybe weren't on the paper, but they had to think about it anyway, right? And as you look at the fuel efficiency, and certainly people are going to want to say, okay, I hear you, but prove it. You've got enough there to make it happen.
Yeah, I mean, the beautiful thing about it is it's the safest truck we've ever built, the most fuel efficient truck, the most connected truck, which means we have data to back up what we're saying. There's a lot more we could dive into on the powertrain, but I'd say one of the areas that we're focused on for North America is rear axle ratios. The traditional spec is a 264, it's a 308. Drivers feel like that accelerates faster. They feel like they get more pulling power in a hill. Honestly, in a hill, your horsepower is going to determine how fast you pull that hill way more than your rear axle ratio. Now, in the past with manual transmissions, rear axle ratios kind of limited you to what you could do because you didn't want a driver to have to make shifts when they're climbing a hill, right? So then you kind of wanted that 264 or that 308. Now, with an I-shift transmission that shifts up to 30% faster than our previous version, we can really get customers into those 215 rear axle ratios, those lower numeric, faster rear axle ratios. They really allow that engine to stay in the sweet spot just a little bit longer, run lower RPMs. If you're running lower RPMs, you're using less fuel. That's going to improve your fuel mileage. That's going to extend your maintenance intervals. So there's a lot we can do with there. And I think the common misconception when it comes to rear axle ratios, right? Have you ever seen a truck driver with a stopwatch timing himself from 0 to 60?
I can't say I have, no.
Okay. So why do they think a 264 or a 308 out accelerates a 215? Well, they hear it. They hear that truck revving up. They hear it shifting those gears, right? And in a 264 or a 308, that truck's going to rev up and it's going to shift gears faster. But you ride bikes, Alan.
Yeah.
No matter how fast you're shifting through those gears, are you accelerating any faster?
No. Not really. You talk about these rear axle ratios and the comparisons. You didn't leave it just with a statement. You actually went out and put it on the road. Sort of. Yeah, as we were preparing for in-person launch activities where we brought almost 1,800 customers and dealers and technicians through our Volvo Trucks Customer Center in Dublin, Virginia, we wanted to be able to showcase what we were talking about, right? That the 215s would pull and they would accelerate, that they would do the same job, but they would do it much more efficiently. So what we decided to do was have a drag race. And we're not talking Top Fuel Dragster, right? It's not John Force, Cruise Pendragon. It was trucks, so keep that in mind. But we decided to race a all-new VNL with a 215 rear axle ratio, and then we had a legacy VNL that had a 247 rear axle ratio. And what we found in this race was that the 247, because people think, the higher numerical ratios will accelerate faster, it did for about the first 100 feet. It really leaps off that line, and you'll see that in the video. But what happens is the trucks accelerate, the 215 continues to accelerate faster and faster, staying in a gear longer. The 247 is going to shift gears like we talked about, clicking through those gears quicker. Yeah. It's going to click through gears faster, but the 215 is able to stay in that sweet spot, accelerate faster, put more torque to the ground, and do the job at way less RPMs using way less fuel. I have to ask, you have a racing background.
I do.
You come out of that area. Was this your idea?
It actually wasn't. I can't take credit for the idea, and they actually didn't tell me about it until after they'd done it because they knew I would have wanted to be involved in it. So they actually hired professional drivers to do it, and they didn't let me take part. I was kind of bummed about that.
And so we did have the "Don't try this at home" disclaimer.
Yeah, don't try this at home. But, for truck drivers, every, on-ramp is their drag strip, so to speak, right? Like they need to get up to speed and they need to be able to merge into traffic. And what we wanted to show was, hey, You can do that with a 215 rear axle ratio. And from the driver perspective, they're going to enjoy the quietness of the ride from those lower RPMs, especially when they're on the highway at those cruising speeds. So
Sure.
it's a big win.
You know, Kyle, you have used basically "this changes everything," designed to change everything, as the moniker, the go-to slogan for this truck. And I think over the months we've been able to dive into that in different aspects. I'm going to give you the final word on the final episode of the VNL for Truck Tech, with what it is that you want people to take away.
We want people to take away that at Volvo Trucks, we never stopped at innovation. We never stopped striving for perfection. Can we ever get there? Probably not, but we keep chasing that. You know, we've got a vision towards a zero emissions future. We have a vision towards a future where no Volvo truck should be at fault for an accident. That's why we continue to work on our active safety. You know, when we think about passive safety, safety's been in the Volvo DNA, since the company was founded. You know, we actually invented the 3-point seatbelt back in 1959. We didn't patent that product. We shared it with the world. So what we really want people to take away is that today we've reset the standards in North America. We've brought the most fuel efficient, most connected, safest truck ever designed for this market. And we've really set the new standard. And we're looking forward to getting drivers in it across North America.
No better way to finish than that. Thank you, Kyle.
Thanks, Alan. Appreciate it.
Well, folks, that's it from the Volvo VNL perspective, and that's quite a bit, really. You can catch all of the previous episodes that we've done on the Volvo VNL, the all-new Volvo VNL, on the playlist at FreightWaves.com on the YouTube channel. Go back and find some of those. We think there's some really great insights that have been shared over time. We thank Volvo Truck for bringing us to this particular place here in High Point, North Carolina, near their North American headquarters, to do some of this work. And we thank all of the guests that we've had from Volvo Truck, giving us their time to do these shows. Thank you for watching, and we'll see you next time.